Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle. Audio Jungle.
Okay, right now I would like to explain you a simple explanation about bending. Bending is a characterized behavior of an object, of an slender structural object when subjected to a external load perpendicular to its longitudinal axis. Like this ruler, when we apply load perpendicular to its longitudinal axis, it will bend. Motion due to bending moment is quantified by the curvature of the neutral surface, like this. And to calculate the radius of curvature, we use this formula. And beam is concave upward where the bending moment is positive, and it will be concave downward where the bending moment is negative. Curvature occurs where the magnitude of the moment is at maximum, in this case in the middle part. So to calculate the beam shape or elastic curve, an equation is required to determine the maximum deflection and shape and slope, which is we use this formula. And for more detail, my friend Azri will explain you in the calculation part.
Audio Jungle.
Okay, now I will show you example of calculation from what was Muiz explained before about the theory. So for this example, I took a beam with a two support, which the support is at A and E. So from this example, we need to find the deflection at point C, at the center of the beam. Okay. From the example, first we have to find the summation of force at y-axis. Summation of Fy equals to 0. So from this beam, we just have the reaction at the A, which is moving upward, and at E. So the summation of Fy is Ra minus 17.5k minus 17.5k plus Re equals to 0. So we have to find the Ra and Re. First, we simplify this equation first. Okay, then we have to find the summation of moment. From it took the moment start at point A. Oh, sorry, it should be 35. Okay, now we will calculate the moment from point A. Okay. From point A, we have the force at B, which is rotating at clockwise, which means it will be negative 17.5k times the distance from A to B. So we assume this from A to B is around 0.8, and also goes to D and E. Okay, so 17.5 times 0.8 minus this point, at this point 17.5k times the distance from A to D, which is 1.7. Plus the RE. The RE times by 2.5 equals to 0. Okay, now we have to simplify until we get the amount of RE. The RE is 17.5k. So this is the first equation, and this is the value of RE. So we substitute the the value of RE into the first equation. So RA equals to 35k minus 17.5k. That means the RA is 17.5k Newton. So after we got the RA and RE, we will develop an equation of moment. Okay. We take the beam, took the moment to the A and B position. This is the center of the beam. Okay, so now what is the force at A? The force at A is 17.5k. B also 17.5k. Okay, now we assume there's between B and C is x, the distance between B and the center. So how we develop the equation of moment? Summation of moment equals to 0. That means from A, negative 17.5k times A to B is 0.8. So times 0.8, plus x plus 17.5k times x times the moment equals to 0. So after all, we will get the moment equals to 14k Newton meter. Okay, now we will calculate what's the maximum deflection at the point C. So maximum deflection, we use the formula d square y dy over d x square equals to m x over ei. This is the formula as what told by Muiz. So what we have to do with the formula, we have to integrate it. So we integrate the dy dx and also at the right hand side. Integrate dy. We bring in the ei here. M at x. This one is the moment at x. So after the integration, we will get the dy over dx. Don't forget the ei. We have to multiply it, equals to the moment at m. What is the moment at m? The moment is 14 kx. After integration, we will get the x plus c1. Okay, then from the dy dx, we will integrate more. Now the next step is we have to integrate the dy dx. Then it will be like this. That means the last equation is ei times y equals to 7k x squared plus c1x plus c2. Alright, so we have to find the c2 first. How to find it? We substitute the value when the position x at 0 and y at 0 into this equation. So he will get 0 because ei times y 0 equals to 7k times 0, that means 0, plus c1 times x also 0, plus c2, so that means c2 is 0. Okay, now, okay, this value actually is at support A. Now we have to find the the x is 2.5 but the y still 0, so we substitute the x equals to 2.5 and y equals to 0 into the equation. So ei times y till 0 equals to 7k 2.5 square plus c1 2.5 plus c2 is 0, that means 0. So we have to find the c1. Okay, in this case the E, we assume the E equals to 200 gigapascal and the I is 223.9 times 10 power of 6 millimeter. Okay, so we substitute the number into this equation. So 200 giga times 23.9 equals to, so that after the substitution it will be like this. Okay, now the amount of C1 is okay, we got the C1. Now what we have to do the C1 with the C1? with the C1 we can find the Y maximum, which is the deflection at point C, which is at the center of the beam at the Y axis. Okay, now we turn from the equation EI times Y equals to 7K. The C1 is negative, so negative 17.5 kx. C2 is 0, so don't need to write it. We transfer the I to the right side, so Y max equals to 7 kx square divided by EI. Okay, now we can calculate the Y max. Substitute the number. Okay. Y max equals to since the distance from A to center is 1.25, so we'll substitute 1.25 into the x. E is 200. I is 23.9 times 10 power of 6. Okay, now the final answer is negative 2.288 times 10 power of negative 3 meter. That means the beam is bending like this. It bending downward. This one is the support, and it bend 2.288 millimeter downward. Okay, that's all. Thank you.
Audio Jungle. Audio Jungle. Audio Jungle.
Thanks by our friend for the explanation about the bending. Now I will explain about the application of the bending to the aircraft wing. On the aircraft wing, we'll experience two main forces, which is the upward force and the downward force. The downward force occurs by the existence of the engine, the weight of the engine, while the upward force is received by the lift force acting on the wing. The lift force acting uniformly for the wing, uniformly below the wing. Now I will explain about what happened for the wing, for the upper surface of the wing and the lower surface of the wing. For the upper surface of the wing, we'll experience compressed force, while the lower surface of the wing will experience tension force. Now I will explain about for the end of the wings. It is a free end, so it will experience more forces along below the wing. So the wing will a bit bend upward because of the force acting at the wing. maximum force acting on the wing at the wing tip. Moment at this side is anti-clockwise due to the moment along the aircraft. The wing is clockwise.
Audio Jungle.
Okay, another example in application of bending is weightlifting. As you can see, our friend right now, his hand act as the support. Weight at the both end of the bar will give the force downward, and the bending occurs at the middle of the bars.